likelihood of rolling a total of 10 with 3 unbiased 6-sided die. So think from first principles here. The sum has to be 10. So how do we compose a sum of 10 using 3 values? And each value can be 1 to 6. So if the first value is 1, the next smallest is 2. 1 plus 2 is 3 and 7. So this is impossible because dice goes from 1 to 6. So this is not possible. Consider 1, 3. Increment this by 3. Sorry, increment that by 1. So we have 1, 3. So the smallest value here, 1, 4, is going to be 6. So 1, 3, 6 is a valid combination. So now let's continue with this pattern. 1, 4, or 1 plus 4 is 5, then we have 5, and 1, 5, then we have 4. But this is just this permuted. So just consider the numbers without care to order. So we only have this possible sequence and this possible sequence where one such value is 1. Okay, so that checks out. And what about the first number being 2? Well, the next smallest is 3, and then we have 5. 2, 3, 5, that's valid. 2, 4, 4, that's also valid. And 2, 5, well, then it has to be 3, so that's the same as the first case. So we have 2 more cases here. And now let's consider the first value being 3. Well, the next smallest is 4. Actually, we could try the same value. It could be 2, 2, right? 2 plus 2 is 4, and then 6. This would also work. So consider that as well. So we have 3 and 3 and 4. That's valid. And 3, 4, well, obviously 3, 4 goes to 3, so that is not needed. And 3, 5, 2, well, we already considered it previously. So all the other stuff, we don't need to consider it. We only get 3, 3, 4 from this case. And what about the first value being a 4? Well, 4, 5, 1. 4, 5, 1 is included already. So all subsequent values must be included and have already been counted, such as, well, actually, you can't even go on, right? Because 4, 6, 0, that's not possible. So these are all the possible sums. Every die we need to have these numbers appearing, or these numbers and etc. for the sum to be 10. So consider each of the cases. What is the probability of each of these valid outcomes happening? So call this case 1, case 2, case 3, case 4, case 5, and case 6. So case 1, we have 1, 3, 6. So 1, 3, 6, well, how many ways are there to permute it? There's 3 factorial ways to permute it. And the reason why we permute it is because this will correspond to the number of ways where the die have each of the unique values. So consider die 1, die 2, die 3. Permuting it will just say, okay, these are all the possible ways that the die can have the valid numbers that we're looking for. So just to enumerate it, it will look like this, right, after permuting everything. There's 6 ways here, and each of them is a valid sequence of values that D1, D2, and D3 can have such that the sum is 10. So 3 factorial, but what is the probability of each valid sequence here? Well, each number in a fair die has a 6th chance of happening. So that's 1/3, that's 3 factorial times 1/6 raised to the 3rd power, right? So that's case 1. We have that out the way. And what about case 2? Well, case 2, all numbers are unique. So we have 3 factorial and 1/6 raised to the 3rd power. Again, what about case 3? All are unique. We have the same thing again. What about case 4? Well, we have duplicates here. So what that means is we need to be careful here, because if we count, right, 2, 4, 4 is the same as 2, 4, 4 if we permute it, because we will swap these two. So we have to get rid of this overcount. So how do we do that? Well, there's 3 factorial ways to arrange 3 unique values, but 2 of them are not unique. And there's 2 factorial ways to arrange the 2 same numbers amongst themselves. So divide this by 2 factorial, and we get the number of valid permutations. Each permutation, like 2, 4, 4, has a 1/6 to the 3rd chance of happening. So that's case 4. What about case 5? Well, that's the same as case 4. So that's 3 factorial divided by 2 factorial, 1/6 to the 3rd. And what about case 6? Same thing. 3 factorial, 2 factorial, 1/6 to the 3rd. So sum it all up, and we should be good. Case 1, case 2, case 3 all have the same probabilities, right? So therefore, that's 3 times 3 factorial times 1/6 to the 3rd. Plus this, and this, they all have the same probabilities. 3 times 3 factorial divided by 2 factorial is just 3 times 1/6 to the 3rd. Factor out 1/6 to the 3rd. 1/6 to the 3rd times 3 factorial is 6, so 18 plus 9 is equal to 27 divided by 6 to the third. Now, 27 is 3 times 9, 3 to the third, so 3 times 3 divided by 6 times 6 times 6. As you can see, everything's canceled by 3, so that's 1 times 1 times 1, 2 times 2 times 2, which is 1 over 8. So your answer is 1 over 8.